In this video, I'm going to be modeling for you how to represent whole numbers as a fraction. So here I have three examples, and I'm first going to do a drawing for you so you can visualize this, and then we're going to put them on the number line. So here I have 3 over 1, and what that means is 3 wholes. And even though it's a little awkward, I tell my students that even though we read fractions from numerator to denominator, I actually think about fractions from denominator to numerator, because the denominator is going to tell me how to partition my whole, and then the numerator is going to tell me how many of those parts we are looking at. So here, my denominator is telling me that my whole is going to be left as one whole, and that I need 3 of those. So 3 over 1, or 3 wholes, looks like this. I have left the whole in one piece as a whole, but I need to do that 3 times. So here I've done that 3 times. So another simple way to say that is it just represents the number 3. Similarly here, so I see 8 over 1, or 8 wholes, and what this 1 means is I'm going to leave the whole as a whole, but I need 8 of them. I need to do that 8 times. So here, and again, I'm not partitioning them, I'm leaving them as a whole, but I need to use 8 of them. So a simpler way of writing it is just 8, but we do need to recognize them when the 1 is the denominator. Now, 5/5, here, my denominator is telling me I need to partition into fifths. Now, fifths is not one we use often, so there's no relationship to use this, then that to get to fifths. So here I have fifths, I've partitioned into fifths, and I need all 5 of them. So here I've shaded in 5/5, I've shaded in my whole thing, so a more simple version of that is 1. I have used 1 whole. So whenever you see a numerator and a denominator as the same, it represents 1. Anytime the numerator and denominator are the same, it represents 1 whole. Here I would partition into thirds and use all 3 of the thirds. Here I would partition into halves and use both of the halves. All right, so here I have these 3 numbers that I have represented as whole numbers, 3, 8, and 1, or 3 wholes, 8 wholes, and 1 whole. And now I'm going to put them on the number line. And what I like to do is I like to find my smallest number. Here's my smallest number, and here's my largest number. And I know that then that needs to be my range. So here I could start with 1 and then put 8 here. And then I could do my best to partition it equally, because on the number line they do need to be as equal as we can get them. It's not as important as when we're doing fractions, but I still need to try. So here I'm going to give, this would be 2, 3, 4, 5, 6, 7. So here I'm going to put 5/5, because that has the same value as 1. Then I'm going to put 3 over 1 here, because that has the same value as 3. And then I'm going to put 8 over 1, because that has the same value as 8. And I could, if I wanted, I could fill all of these in with their fraction representation. Right there. So use this when you're thinking about how to represent whole numbers as a fraction. Sometimes it's the denominator is a 1, letting you know you are going to leave that whole as a whole, no partitioning, but you need many of them. And sometimes it's when the numerator and the denominator are the same, so you will be partitioning, but then you need all of the partitioned units, like these. All right, so use those ideas and then think about what is your smallest and largest numbers when you're finding your range on the number line. I needed 1 all the way to 8, and then I was able to do my best to break it apart into the other whole numbers.